So I'm Dr. Jenny Hutchings from Oregon State University, and I'm involved with MOSAiC to investigate the dynamics of the ice pack around the ship. So what is sea ice dynamics? Well, first, let's just take a look at the ice in winter. So I'm going to be going to the ice camp in leg 3, which is in January, and the ice might look something like this. It looks like land. We would call this an icescape. This is a camp that I was at in 2007. Those plywood boxes we were living in. And you can see over here, there's a snow machine going out to do some field work. And it really isn't apparent when you're on the ice that it's moving, unless you start looking in a little more detail. So here is the GPS track of that snow machine as it went out to the field site and came back. What do you see? It's following the same path. It was going along the same route that was marked out with stakes to the same site, and then coming back along that path. And you'll see that when it gets back to the ice camp after having left, it appears to be in a different location. The ice has actually moved. And the take-home message from this is really never use a GPS track to navigate back to your point of to the point that you left from when you're on sea ice, because the ice is moving and your GPS position when you're standing in one place is changing. Okay, if we venture a little further away from our field camp home, you might encounter cracks in the ice that open into leads and then they ridge. So this is an aerial photograph of that ice camp, and around it you can see a lead and ridges, and those leads are cracks in the ice that are opening. These are what I'm interested in studying, and they're ubiquitous features of the ice pack. You see them everywhere, and they complicate navigation too. So if you're trying to travel across the ice on skis or with a snow machine or walking, you don't want to really cross where the leads are because there's thin ice there or there's no ice. So they have open water in them. And if you're a ship traveling through the ice, you might actually want to find leads because leads lead you through the ice pack. That's why they're called leads. You can see where the camp is there. This camp was built on thick old ice that we hope would survive through May, when the camp would be taken down. And there is level first-year ice next to that camp, which has the lead running through it and new ridges. This was a runway to bring personnel into and out of the camp and supplies to the camp. Very different setup from MOSAiC, but we were studying the dynamics around this camp in very much the same way as we will be at MOSAiC. The difference is that that ice camp was on 10-year-old ice, or maybe older than 10-year-old ice, that we will not see where we're going with MOSAiC. We will be studying the younger, thinner ice there. As that crack opens into the lead, the wind directions can change, and the lead might close, and it might form a new ridge, which you can see on the bottom of the image, that a new ridge has formed out of a lead that opened, and then another lead is opening along that ridge. This is the ice dynamics that we will be studying. Just to give you some idea of what this might look like, I have some movies that my colleague Andrew Roberts made at that same ice camp. This is a ridge that we're looking at, and you can see a time-lapse series of photographs showing the motion of that ridge over a couple of days. See the shearing as the back of the ridge is moving relative to the front of the ridge. This is a crack moving, thin new ice growing in the crack. And this is the same crack with the ice moving up against the thin new ice moving up into an older ice flow. So this is how the ice is moving. It's constantly moving all around us when we're out there. on the ice pack. And if you were to look at the ice motion across the whole Arctic, you'll see a picture that emerges something like this. So we're now looking down on the top of the planet onto the Arctic Ocean. You can see the Beaufort Sea, where Alaska is in Canada, and the central Arctic Ocean. And in the Beaufort Sea, you see a gyre. The ice motion is moving around in a circle. On the other side of the Arctic, towards Europe and Siberia, you see the transpolar drift stream, where the ice is moving across the Arctic. We will be in the transpolar drift stream. This is where the polar stern is going to be positioned, or has been positioned. So in October, it was deployed in the drift stream, and it should drift with the ice. One thing to keep in mind is this picture of the ice drift that I'm showing you here is a representation of the climatology of the ice drift. That is where the ice drifts on average over a number of years. So you will see that the ice drift on average will be towards the Greenland Sea and towards that gap between Greenland and Svalbard, which is the Fram Strait. We play a little game. Where do we think the ice is going to drift? Where do you think the polar stern will drift over the course of the experiment? Thomas Krugman from the Alpha Wegener Institute has estimated the likelihood of the polar stern drifting towards the Fram Strait over the North Pole region. He's taken 13 years of data of ice drift in this region, and the map here is a composite of tracks of the last 13 years of ice drift. And you can see that almost all of those tracks from where we are deploying in the transpolar drift are heading towards Fram Strait. And you can see there's considerable variability in our spread across where those tracks go. And there's also more looping in the tracks than you see in the previous cartoon showing the mean ice drift over 30 years. So if we look at where the polar stern has gone to date, we can see that we moved into the ice and it was deployed where that star is in October, and it is now moving across the Arctic as we expect in the transpolar drift. Okay, question for you. What is causing the drift? So maybe it would help you to think about how the ice is drifting by looking at how it's drifting. This is an animation made by Tom Agnew, who's from Canada, of satellite imagery. It's a composite of satellite imagery. It shows the ice moving around the Arctic Ocean. If you look at the gray, that's the ice surface. You'll notice that that gray surface is evolving in time, and you can actually see it moving around in the Beaufort Gyre. Can you see how it's cracking and opening? Those are leads. They're opening. They're very large leads. So that's the motion that we want to be able to measure and understand why it's happening. It's related to the winds. So the winds are moving the ice pack, and the winds are moving the ocean. So what path will the ship actually follow? This is what we're interested in studying. We want to improve our models so that we can actually improve our estimates of the ice drift.